I hope the board is visible to all of you. Is it visible, everyone?
Yes, sir.
Yes,
Right. So we'll quickly discuss some questions from electronic device and circuits. A very important chapter. Let us hope that whatever we are discussing from in this chapter, right, at least some questions may turn up, right, in the final examination, which is just 3 days away, to be precise, less than 3 days away, guys. Okay. So let us see some questions again. First thing they are asking, better material for solar cell. So usually in case of solar cell, selenium will be used as semiconductor, guys. So the better material will be cadmium, selenium will be the better material for solar cell again. Next case, if you see the two identical capacitors A and B are charged to same potential, it seems, right, and are connected to two are connected in two circuits at t is equal to 0 as shown in the figure. Right. So what they are asking, the charge on these capacitor C1 is Q1 and on C2 is Q2. At T is equal to RC. The ratio Q1 by Q2 will be how much they are asking, guys. If you look at this particular situation, right here, the two identical capacitors A and B are charged to the same potential and are connected to two circuits at T is equal to 0 as shown in the figure. They're asking us what would be the charge on the capacitors is Q1 and Q2 respectively at T is equal to RC, which is one time constant again, guys. Okay, so they're asking what would be the ratio of Q1 by Q2 again. Now, if you observe, so in this situation, what would be the charge? Here we have only one diode. It is connected to the higher potential, guys. So this will be in forward bias, right? Similarly, this will be connected to higher potential. So this will be in reverse bias again. D2 diode will be in reverse bias. So what are they asking? They are asking us to find. So in this case, the first, suppose if I take the first circuit, guys, I will get the first circuit something in this manner. So you will have a capacitor, fully charged capacitor. Now, how will the diode be? The diode will be in forward bias, guys. The diode will be in forward bias, right? So it is going to behave as a closed circuit. Always remember, whenever a diode is in forward bias, it will behave as a closed circuit. How to identify whether the diode is in forward bias or reverse bias? Whenever P is at higher potential, forward bias. If P is at higher potential, N will be at lower potential, right? So charge again here in this case, decay of charge will take place. So charge will be flowing from this plate. The charge, positive charge will be flowing in this manner. Okay. So you can consider the capacitance is how much beta? C1. So this will behave as a RC circuit. There is no resist, there is no battery in this, guys, the external source. So here discharging is going to take place. And what would be the charge at any instant beta? It will be given as Q naught e power minus t divided by tau, which is nothing but R into C, guys. Okay. Now, if you look at this particular second circuit, if you take, right, will discharging take place in this? Now, as you can see, here you have second capacitor. I have two diodes here, guys. So diode D1 will be in forward bias, diode D2 will be in reverse bias, guys. So here in this situation, you have resistance R. This is C2, right? Here plus and minus. So diode D1 will behave as a short circuit, whereas diode D2 is going to behave as an open circuit. So because the circuit is open, charge on the capacitor will always remain same. On second capacitor, it will be Q2 only, guys. So what would be charge on the first capacitor? So Q1 is the charge on the first capacitor. It will be maximum charge. How much is maximum charge, guys? Let us say it is Q naught. So two identical capacitors. Capacitors are identical, they are charged to same potential. So what we can write charge as, we can write it as C into V. Capacitance is same. So initial charge will be same on both of them. Let us assume it is Q naught. E power at what time they are saying? Minus RC beta divided by what is tau given as? R into C1 you can write, but C1 and C2 are anyhow equal. So I'll write it as RC. Here, charge at any instant you take, it will be equal to Q naught only because the circuit is open, guys. So Q1 value will be Q naught e power minus 1. Q2 value will be equal to Q naught. So from both of these, what we can say, beta? Little bit difficult question again. Q1 by Q2 if I take, you will get Q naught e power minus 1 divided by Q naught, which will turn out to be 1 by E, guys. Clear, all of you? The diode in the first circuit will be in forward bias, so we can consider it as a closed switch. Whereas the diode in the second circuit will be one of the diode. D1 will be in forward bias, D2 will be in reverse bias. So forward bias means short circuited and reverse bias means open circuit. So this particular second circuit is an open circuit. So will charge on capacitor vary? No. So charge on capacitor in second circuit will remain constant, whereas charge on the capacitor in first circuit will exponentially decrease. Okay, so q1 value will be q naught e power minus 1 at a time which is equal to rc, nothing but one time constant, guys. Clear, all of you? Understood, everyone?
Yes, sir.
And next question. The similar type of question was asked in 2019 NEET, guys. The semiconductor used for fabrication of visible LEDs must have a minimum band gap of how much it seems, right? Again, you will get a band gap of how much for LEDs? Forward bias mein रहना है. So I think it would be zero point 0.7 volt minimum. Let me just cross check this question also, guys. Energy gap will be given 12,400 by EG value. So the semiconductor used for fabrication of visible LEDs. Visible LED they said, no? Acha, okay. Very simple logic, guys. The energy gap is basically given as 12,400 divided by wavelength. Wavelength should be used in angstrom. Answer you will get in electrovolt, guys. Visible LEDs means it will vary from 380, 3,800 angstrom to 7,800 angstrom. I want minimum band gap. Energy gap should be minimum, guys. So it means what should happen to wavelength? Wavelength should be maximum. Yes or no? Wavelength should be what? Wavelength should be maximum in order to get the energy gap minimum. So for energy gap to be minimum, wavelength should be maximum. And how much will that be, guys? Maximum wavelength of visible light. So I can write it as 12,400 divided by 7,800, guys. So you can get it as 124 divided by 78, which will be near about 1.8 electrovolt. I hope it is clear, all of you. Understood, everyone? I hope it is clear. Again, based on that, you got 2019, you got a question, guys. Energy gap value is given as 12,400 divided by wavelength. Wavelength I can give as 12,400 divided by energy gap. A and B are inputs to a logic gate as shown in the figure. For the given set of inputs and corresponding output, identify the logic gate. Right? You see, A is open, B is closed, output is not there. A is closed, B is open, output is not there. A is open, B is open, output is there. A is closed, B is closed, output is there, guys. So this happens to be XNOR, guys. It happens to be, this is your XOR can also be given as XOR, and this can also be given as XNOR, guys. What is NAND gate? Whenever both are operated at high voltage, then only you'll get output. 1, 1, 1. Rest all 0 only. What is NAND gate? 1, 1, 0. Rest all will be 1 only, guys. So is that the case? No. What is XOR gate again? In XOR gate, beta, again, even when for XOR gate, if I take XOR gate is basically given as A bar dot B plus A dot B bar. Okay, so whenever they both are at 0, you will get 0 only. 0 and 1, you will get 1. 1 and 0, you will get 1. 1 and 1, you will get 0. This is for XOR gate, guys. So what will XNOR gate be? This will be 1, 0, 0, 1. So as you can see, the answer, whatever inputs are given, it will correspond to XNOR gate, guys. A bar dot B plus A dot B bar will be for XOR gate, guys. It is the output for XOR. For XNOR, if I take whole bar, you will take, guys. You will take it as A bar dot B plus A dot B bar whole bar. This will be XNOR again. Okay, so the output would the given output will be for XNOR. You should remember the outputs for OR, not, or, and, nor, NAND, XOR, XNOR. Okay, so these things you should know. For OR gate, both are at low 0, 0, 0. Rest all will be 1 only, guys. Right? For NOT gate, if input is 0, output will be 1. If input is 1, output will be 0. For AND gate, if both are high, 1, 1, then only 1. Rest all will be 0, guys. For NOR gate, if both are low, then only output. 0, 0, then you have output. Rest all cases, no output. For NAND gate, 0, 0, output is there. 0, 1, output is there. 1, 0, output is there. 1, 1, you are not going to have any output, guys. Okay. So when we talk about AND gate, when will you get output? When both the inputs are operated at high voltage. If both the inputs are 1 and 1, then you will get output for AND. In all the other cases, you will not get output. When will you get output for OR? If either one of the input is 1 or both the inputs are 1. In that case, you will get output for OR. When I say you are getting output for OR, means output will be 1, guys. Okay. So what will be for NOR? NOR means exactly reverse of OR. NAND means exactly reverse of AND. XOR will be given as A bar dot B plus A dot B bar. XNOR will be that whole bar, guys. Clear, all of you?
So,
Yes.
so could you give a brief explanation of logic gates if
ब्रीफ
possible?
वही तो बोल रहा था, ब्रीफ ही तो दे रहा था ना मैं अभी.
I
We'll
mean,
talk
what is
about
like?
it now. Let me just complete.
Okay, sir.
Let me just complete. We'll do that. What is given in this question, guys? A 220 volt AC supply. So which supply is this? Simply 220 volt AC supply is given, guys. It means it is RMS value. Which value it is? RMS value. So it is RMS value is connected between 2 points A and B as shown in the figure. The output waveform. Now, as you can see, it is a step down transformer, guys. Right? So for this value, these are your negative input again. For negative input, as you can see, here this will be at negative input. So V naught diode will be in reverse bias, guys. So what will the output be here? This will be fourth option. This is a half wave rectifier. It is half wave rectifier, guys. So in half wave rectifier, you will get output only for positive half cycles of input. You will not get output for negative half cycles of input. So RMS value is given as 220 volts. It is connected between 2 points A and B. This is your input, guys. What are they asking? They're asking us to find the output. This transformer is which transformer? It is a step down transformer. It is including only one diode. It is a step down transformer, guys. Okay, so what is it going to do? It is a case of half wave rectifier again. It will allow the positive values of input, but it will reject the negative values of input. If you take full wave rectifier, then you will get the answer like this. For full wave rectifier, it will allow both positive outputs of positive input as well as negative input. Okay, clear, all of you? Because if you see, figure shows transfer characteristic of CE amplifier. Choose the false statement. So this region, whenever you plot V naught versus Vi, guys, this region happens to be your cutoff region. In cutoff region, it is going to behave as a switch, which is off. Right? This region, middle region, is called as active region. In active region, it is going to behave as an amplifier, guys. Whereas this region is called as saturation region. In saturation region, it is going to behave as switch, but that now will be a switch on, guys. Which switch is it going to be? It will be a switch on here. So in cutoff region and in saturation region, it is going to behave as your switch. In cutoff, it will be switch off. In saturation, it will be switch on. Whereas in active region, the transistor will behave as a amplifier, guys. Is that clear, all of you? Yes or no? So at Vi is equal to zero point 0.5 volt, transistor is in cutoff mode. Yes, it is a correct statement. At Vi is equal to 1 volt, it can be used as an amplifier. Yes, it is also correct statement. At 2.5 volt, is it in cutoff mode? No, it is in which mode? Saturation mode. This is also correct statement. Final one. So what will be false statement, guys? The third option will be false. It is the variation of output voltage versus input voltage for C configuration amplifier, guys, or for C transistor you can consider. Understood, all of you? Yes or no? Asking us to choose the statements given below. Consider the statements given below. At absolute zero temperature, an intrinsic semiconductor acts as a insulator. Yes, it is true. Because at temperatures which is equal to 0 Kelvin, conduction band is completely empty, guys. Conduction band is completely empty. Valence band is completely filled. Whereas as temperature increases, the conductivity of intrinsic semiconductor will exponentially increase. The Fermi level in the intrinsic semiconductor lies between the valence band and conduction band. Yes, it is going to lie exactly between valence band and conduction band. Choose the correct statements. So both A and B will be correct statements in this case. Clear, all of you? At zero temperature, intrinsic semiconductor is an insulator. Yes, because conductivity is zero. Temperatures greater than 0 Kelvin, conductivity will increase. How will it increase? Exponentially. And always remember, Fermi energy level in intrinsic semiconductor will lie exactly between valence band and conduction band. Valence band will be present below, conduction band will be present above. And Fermi energy level exactly midway between valence band and conduction band. Clear? Next case, if you see a Zener regulated voltage supply, Zener diode, the potential difference across this is 6 volt, right? Iz value is given as 5 times of IL. Across this also current is given. The load current is to be 4 milliampere and the unregulated supply is 10 volt. What is the value of series resistance they're asking? So in order to, so I'll just make it something like this, guys. Just for doing the question easily, I'm just rearranging the circuit something in this manner. I'm just taking this resistor and keeping it above, guys. I'm just rearranging the circuit. Always remember, we are going to obtain the output across the load resistance, and we are going to apply the input here, unregulated voltage supply it is. So what is this input beta? Total unregulated voltage supply is 10 volts. Here load resistance is not given. This is your series resistance. Imagine this to be your load resistance, but although currents are given, guys, what is the current here through the load resistance? 4 milliampere. And it is also mentioned current through the diode is given, guys. What is the current through the diode? 5 times again. Will this be 20 milliampere or not? Certainly it will be 20 milliampere. Now overall, if you see, if you see this junction, guys, 4 milliampere coming out like this, 20 milliampere coming out like this. So it means through the series resistor, will I have 24 milliampere flowing or not, guys? Yes or no, everyone? Now as you can see, what is the potential difference across the diode, across these 2 points? Between these 2 points, what is the potential difference? Already is given as how much beta? 6 volt, I guess. Now, between these 2 points, it is 10 volt. Between these 2 points, it is 6 volt. So automatically, can I say across the series resistance, what will be the potential difference beta? Across the series resistance, I can say potential difference will be 4 volt. So I know the current, I know the potential difference. So can't we find the resistance, guys? Resistance will be V divided by I. Potential difference across resistor and current flowing through the resistor. What is it? 4 divided by 24 milliampere you can write. So I am going to get it as 4000 divided by 24, which turns out to be 1000 divided by 6, which will be 167 ohm. Very important question related to your Zener diode, guys. Right? Zener diode will also act as a voltage regulator. Right? So whatever may be the input supply, potential difference across these 2 points, constant. Potential difference across the load resistance will also be constant, guys. However, potential difference across the series resistance will keep on changing. So is there any element between this point and this point? No element. So whatever is potential here, same will be potential here. Is there any element between this point and this point? No element. So whatever is potential here, same will be potential here. Overall potential difference between these 2 points is 10 volt. So across these 2 points will also be 10 volt. Already it is given potential across the diode is 6 volt. So eventually we can write across the resistor it will be 4 volt. So by using Kirchhoff's junction law, we found out the current flowing through the resistor. We know the current, we know the potential difference. So can we find the resistance? Absolutely, we can find the resistance, guys. Is that clear, everyone? Yes or no? I hope it is constant. Then for transistor amplifier, the voltage gain. What will be the voltage gain, guys? If I plot the variation of voltage gain with frequency, voltage gain we are plotting with frequency, guys. Which graph it is going to follow? At low frequencies, it will be low. For mid-range frequencies, it will be constant. For high frequencies, also it will be low. This will be the variation of voltage gain, guys. Right? For low frequency, low. For mid-range frequency, it will be constant. For high frequency, also it will be low only, guys. Okay. So that would be the variation again. Is low at high and low frequencies and constant for mid frequency. This is the variation of voltage gain with respect to the frequency applied, guys. I hope it is clear, all of it. It's a very important case again. Question, if you see, a PN junction photodiode is fabricated from a semiconductor, right? So it can detect a wavelength up to 12,000. Just now I have given the formula. This type of question came in 2019, guys. And you should get the answer in angstrom again. So I can write 12,400. What is the energy gap given? 2.2 electrovolt. You'll get the answer in angstrom. So what are we going to get? Near about 6,000, maybe 6,000 angstrom you will be getting, guys. Yes or no? 2.26. 6 to is 12 you will get. 6 to is 12, 13. I don't think. So a PN junction photodiode is fabricated. So this is 6,000 nanometer. So this turns out to be into 10 by 10 if you do, guys. This will be 60,000 angstrom. This will not be true. This is 6,000 angstrom anyhow. What will this value be? This is 7,000 angstrom. So it can detect a wavelength less than or equal to this wavelength, guys. So how much will I get the value as? If you just do 12,400 divided by 2.2, near about, I think you will get it as something around 6,000. 5,600 you will get, guys. 5,636 angstrom. So which wavelength it can detect? Up to this wavelength it can detect. So can it detect 6,000 nanometer? No. Will it detect 5,000 angstrom? Certainly it will detect 5,000 angstrom. Very important case, guys. Wavelength will be less than or equal to 12,400 divided by energy gap. Definitely based on this, you will get questions again. P-type semiconductor, always remember, whenever intrinsic semiconductor is a semiconductor in pure form. If impurities are being added, guys, then it will become an extrinsic semiconductor. Again, we have two types in extrinsic semiconductor. One will be a p-type and there will be a n-type. P-type extrinsic semiconductor is obtained when an intrinsic semiconductor to an intrinsic semiconductor, if you add trivalent impurities, group 13 elements, guys. Similarly, you will obtain n-type when to the intrinsic semiconductor if we add pentavalent impurities. So both will be electrically neutral. Whether you take p-type or n-type, they will be electrically neutral only, guys. Clear, all of you? Now let us talk about this circuit. Listen, Vaishnav, huh? See, this would be the expression for your AND gate, guys. This is the um, this is how you represent a AND gate. Okay. Now you have input A and B. Okay. Now in front of AND gate, if you keep a circle, it becomes NAND gate, guys. Which gate is it going to become? NAND. If you had AND gate, the output would have been A into B. But because it is NAND gate, I will get A dot B whole bar, guys. This will be the output. Now if you see, it is one input only. Now the same input is now given to, again you see which gate is this? This gate you see, guys, only this part. This is which gate? It is again your NAND gate only, guys. Same input A dot B whole bar is given as two inputs for NAND gate. So basically this is your NOT gate. This is the expression for NOT gate again. This is NOT gate derived from overall, if you see, It is not gate derived from NAND gate, guys. Output of NAND is given to NOT. Output of AND is given to NOT. It will become NAND. Output of NAND is given to NOT. It will become AND, guys. So this is totally, this is your NOT gate. This overall is your NOT gate, guys. This overall will behave as your NOT gate. This is which gate? This is NAND gate. What is this gate, beta? Overall, it will behave as a NOT gate. So whenever output of NAND is given to NOT, what are we going to get? We are going to obtain AND gate, guys. We'll be obtaining AND gate. In the same manner, you see, here zeros are kept before, guys. So when zeros are kept before, it means 0 means it is not beta. You can write it in terms of triangle also, but simply if 0 is given or triangle is given, it is a not gate. So now you see, here you have A, here you have B. So what will I get here? When A is given as input to not gate, I will get A bar. When B is given, it is B bar. Now what are we going to get? These two are applied as inputs to which gate, beta? This gate happens to be a AND gate, guys. Which gate is it? AND gate. What is the output of AND? Input A bar and B bar. AND means nothing but multiplication, guys. I'll get A bar dot B bar. Now, if you look, one input only, I am giving it as, I'm applying it to both the inputs of NOR gate, guys. This is your NAND gate. In the same manner, this will be your NOT gate derived from NOR gate, guys. This will be your AND gate. Okay, this is your AND gate. Now, whenever common input is given to a which gate, beta? NOR gate. It will behave as a NOT gate, guys. So overall, if you see, what will the output be? I'm going to get the output as something like this, no? A bar dot B bar, because this is NOT gate will invert again, guys. Is it in the form A dot B whole bar? Yes, it is in the form A dot B whole bar. What is A dot B whole bar as per Boolean algebra? It is A bar plus B bar. A bar whole bar is nothing but A plus B. A plus B is nothing but which gate, beta? OR gate. So what will our corresponding gates be? It will be AND as well as OR gate, guys. This is NAND gate. This is overall NOT gate derived from overall, guys, not simply this value. This is your NAND gate again. Overall, if you see, this is NOT gate derived from NAND gate. Okay. Here, whenever circles are given, guys, they represent NOT gate again. Okay. Am I audible? Am I audible, guys? Where did we lose connection? At which question?
Said the answer, sir.
Which answer?
So that logic gates one.
Acha, we lost connection there. And
Yes, sir.
none of you are saying anything in the group or anything like that. ठीक है. Is the answer done? Did you understand that, or till where did we?
So how did we got that NOT gate? I mean, you said that is an AND gate. Then how did we
Which
got it
which
as NOT?
is which is NAND gate?
So the first one, the
This is
first one. Yes, sir.
this only this part is your NAND gate. But to NAND gate, I am applying same input. See, this is the output for NAND gate. This will be applied as input to this gate. You have only one input. Same input is being applied or not?
Yes, sir.
So whenever same input is applied to NAND gate, it will behave as a NOT gate. In the same manner, you see, same input is applied to which gate? NOR gate. This will also behave as a NOT gate only. Understood?
Yes, understood.
Did till here were we in connect till here, guys?
Yes, sir. You give the answer, sir.
Acha. We lost the connect in the next question.
Yes, sir.
What is given in this question? A 200-volt AC supply. Always remember, it's very important, guys. In 2021, you got a question based on this again. 2021, if I'm not wrong, right? Same AC question only they were given. They were asking you to find peak value again, peak value of electric field or some question they asked, guys. So here, 200-volt AC supply. AC means it is alternating. Yes or no? Alternating means it should vary with time and it should be periodic. But here you see simply value is given, guys. Whenever simply value is given instead of a sinusoidal function, then this value will happen to be RMS value. They are asking us what is the final potential difference across the capacitor. Means they are asking peak value, guys. So what is RMS value here? Basically, we write in sinusoidal function, we'll write RMS value as V naught divided by root 2. I'll get V naught value as root 2 times of VRMS. So I'll get the answer as 200 root 2 volts, guys. This will be the maximum value or the final potential difference across the capacitor, guys. Initially, potential difference will be 0. Now, the diode will behave, for positive half cycle, diode will be in forward bias, guys. So, you are going to have maximum potential difference, which will be 200 root 2 volts. Clear? Question you see? I'll just redraw this once again, guys. You see, from here, what we are getting? A. Yes or no? Is A the input? Yes. Similarly, from here, what we are getting? From here, you are getting B. From here, what you are getting? B again. But you see, A is given as input to which gate is this? Not gate, guys. So what are we going to get here? A bar. Now, what are the two inputs applied? Which gate is this? AND gate. What are the two inputs applied? A and B, guys. So what are we going to get? AND stands for multiplication. A and B. Here you see one of the input is A bar, other input is B. Again, it is applied to AND gate only. So what are we going to get? A bar dot B. Now, one input is A dot B, other input is A bar dot B. Both are given to OR gate, guys. So what will our output be? It will be A dot B plus A bar dot B. It is also similar to previous year question only, guys. Okay, now you take the truth table. A is there, B is there. You can take A bar, you can take. Similarly, you can write A dot B, you can write A bar dot B. You can take Y also, guys. Now, if you take this situation, see what are the basic inputs that you need to take. Generally, you will be given two inputs, guys, except for NOT gate, because NOT gate is the most basic gate. It will have only one input and one output. Now, how will you generally take a truth table? This input can be operated either at low voltage or at high voltage. If A is being operated at low voltage, B can either be operated low or high. If A is being operated at high, B can either be operated low or high. This is how you take it. 0 0 0 1 1 0 1 1. This is basically inputs, guys. Now what will A bar be? Negation of A. 1 1. Yes or no? 0 0. What is A dot B? A and B again. 0 into 0 0. 0 into 1 0. 1 into 0 0. 1 into 1 1. What is A bar dot B? 1 into 0 0 only. 1 into 1 1. 0 into 0 0. Right? Similarly, 0 into 1 0 only. Now I have A dot B plus A bar dot B. 0 plus 0 0. 0 plus 1 1. 0 plus 0 again 0. 1 plus 0 1. So what will you get? 0 0 you got output as 0, guys. 0 1 you got output as 1. 1 0 you got output as 0. 1 1 you got output as 1. So which will be the correct explanation here? Fourth one would be the correct truth table. So in logic gates, you just need to know what is the symbol of the logic gate, what is the corresponding Boolean expression, right? And what would be the truth table, guys. Also realization circuit. Four things you need to know in each gate. What is the symbol for the gate? What is the Boolean expression, right? Then in the same manner, what is the truth table for that particular gate and what is the realization circuit? These four things you should know in different type of gates. Not, or, and, nor, NAND, XOR, XNOR. Okay, guys. So these are the 7 gates that you should be aware of. Understood? 10. IV characteristics for two semiconductors. You see here, negative potential means it is in reverse bias. The photodiode usually will be in reverse bias. And IV characteristic in fourth quadrant will be for solar cell, guys. So the answer will be for photodiode and solar cell. If they are asking LED, for LED, it will be in first quadrant, guys. Because LED is operated in forward bias. Photodiode will be operated in reverse bias. Solar cell, there is no biasing condition again, but still, in fourth quadrant, you will get the IV characteristic for solar cell. Understood, everyone? Choose the correct option for a semiconductor, it seems. It has negative temperature coefficient of conductance. No. As temperature increases, what will happen to conductivity? Exponentially increases. For pure semiconductor at room temperature, Ne and NH both are equal. Yes. Ne and NH both will be equal, guys. In the same manner, it works as insulated at 0 degrees Celsius. Na, 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 na. Don't write it as 0, huh? It will work as insulated at 0 Kelvin, guys. So which of them will be correct statement here? Second one will be correct statement, right? For pure semiconductor, which is nothing but your intrinsic semiconductor, Ne value and NH value both will be same. It will work as an insulator at 0 Kelvin, right? It has a positive temperature coefficient because as temperature increases, conductivity will exponentially increase, guys. Here, all of you. Now you see the output of the given circuit in the figure shown. What will it be? They are saying input is what, guys? Let us apply. This is our input. Let us assume that our input is something like this. Okay, this is a alternating input, guys. Now, for positive half cycle, you see, whenever positive half cycle is there. Now, whenever we have positive half cycle, you can imagine if I redraw the circuit like this, guys. For positive half cycle of input, this will be your V naught value. This is your R. Resistance, you can consider it to be R. Now, for positive half cycle of input means this end will be at higher potential, this end will be at lower potential. It means N will be at higher potential, P will be at lower potential in this case. So during this cycle, N is at N is high, okay, and P is at low potential. In the same manner, during negative cycle, guys, N is low and P is high, guys. Again in this positive half cycle, N is high, P is low. So what is the situation in this? So during positive half cycle, are we going to get any output, guys? No, you're not going to get any output during positive half cycle, right? In the same manner, uh, so we can directly say it is halfway rectified, right? So which cycle will be in the output? Obviously, positive cycle will be in the output, guys. Yes or no? What will uh, what will out, what will uh, rectifier do? It will allow only positive half cycles to flow, guys. So it is going to behave as a half-wave rectifier. It has only step-down transformer, right? So it is going to behave as a half-wave rectifier. So it will be half-wave rectified with positive cycle in the output, guys. Understood, everyone? Clear, all of you? During positive half cycles here, diode will be in forward bias, and during negative half cycle, it will be in reverse bias, guys. Sorry, during negative half cycle, it is in forward bias. During positive half cycle, it is in reverse bias. So during positive half cycle, you will have conduction. Okay, because during positive half cycle, through diode, you will have conduction during negative half cycle, guys. Okay, so it is anyhow behaving as a half-wave rectifier. Because if you see, choose the wrong statement. The resistivity of semiconductor belongs in the range 10 power minus 5. Yes, it is correct statement. At 0 degrees Celsius, semiconductor behaves as conductor, it seems. 0 degrees Celsius means, is it minus 273 Kelvin or not, guys? Yes or no? Sorry, plus 273 Kelvin or not? Right, so will it behave as a conductor? Yes, because it is temperature more than 0 Kelvin. When arsenic is doped in silicon, arsenic happens to be pentavalent impurity, guys. Then it becomes N-type. Yes, this is also correct. So which will be the incorrect statement, beta? Energy gap in carbon is greater than energy gap in silicon will be the incorrect statement. Clear, all of you? Yes or no? 0 degrees Celsius means 273 Kelvin only, no? So at 273 Kelvin, will it behave as conductor? Yes, it will behave as conductor. Energy gap in carbon is greater than energy gap in silicon. When arsenic is doped in silicon, then semiconductor becomes N-type. Is group 15 only, no? Yes or no, yaar? Group 13 क्या है? Boron family, aluminum family, you can write. Case if you see, pure semiconductor crystal has how many atoms they have said? The pure semiconductor crystal has 4 into 10 power 27 atoms per meter cube. It is doped by 4 parts per million concentration of pentavalent atom. The number of holes per meter cube will be how much they are asking, guys. 4 parts per million means for 1 million you are going to have 4 parts, guys. 4 parts of pentavalent atom. Okay, so overall a pure semiconductor crystal has 4 into 10 power 27 atoms. It is doped by 4 pentavalent atoms per million of atoms, guys. So what are the number of holes they are asking again? So Ni value is given as how much, beta? Ni value is given as 10 power 16 over here. So whether it is a N-type or P-type, whether it is intrinsic or extrinsic, we can write intrinsic charge concentration will be Ne into Nh, guys. The pure semiconductor crystal has 4 into 10 power 27 atoms per meter cube, and it is doped by 4 part per million concentration of pentavalent atoms. The number of holes per meter cube they're asking. So what would be the situation, guys? Pentavalent atom means number density of electrons will increase or not? Pentavalent impurities are being it is doped by 4 ppm concentration of pentavalent atom here. Ni value is given So I need to find pure semiconductor crystal has 4 into 10 power 27 atoms, guys. It is being doped with 4 parts per million concentration of pentavalent atoms, it seems. So what we can consider here, if you use basic unitary method again, 4 parts per million means 4 into 10 power 6, no? So initially you have these many atoms. So whenever a pentavalent atom is added, you will get one extra E value, guys. One electron excess you are going to get. Okay. 4 parts per million means what we can take Ni square, so you will get it anyhow. So NH value they are asking, which I will get it as Ni square divided by Ne. So what is Ni square beta? It is 10 power 16 whole square. Divided by Ne you can write, which will be 10 power 32 divided by Ne value I should find, guys. So for each, it is doped by 4 parts per million. It means for 10 power 6 atoms, how many impurities are being added, guys? 4. But overall I have how many atoms here? 4 into 10 power 27 atoms I have. So how many will be added? X, let us say. So can I write x into 10 power 6 will be equal to 4 into 4 into 10 power 27 atoms or not? So I'll get x value as 16 into 10 power 21 I will get. So if I use 16 into 10 power 21, I'll get 10 power 11 by 16. Maybe some mistake I'm doing in this case. Just see. 10 power 32 you will get here divided by, see, for one atom, when one pentavalent impurity is added, I am going to get one electron extra. It is doped by 4 parts per million concentration of pentavalent atom. What is the meaning of this, guys? Overall, it has 4 into 10 power 27 atoms. Okay. So I have for for 10 power 6 atoms, I have 4 impurities being added, or 4 parts per million. Is it 4 into 10 power 6, guys? Okay, just keep this aside. I'll just do it. Some unitary method we are doing wrong. 10 power 11 only you should get as the answer, guys. Near about 10 power 11. Okay. For a PN junction diode, potential V0 is shown for unbiased condition. Right? Now, in this case, so always remember, in unbiased condition, you have some potential barrier. In reverse bias condition, potential barrier will increase. In forward bias condition, potential barrier will decrease. So if you see, first case, if it is unbiased, 2 and 3 potential barrier is increasing. So I can say both 2 and 3 represent reverse bias, guys. In forward bias, the potential barrier value will decrease again. Yeah. Then you see, next case, energy band diagram of a semiconductor material is given. So basically, if I take, we have conduction band over here. Valence band will be below conduction band, guys, as you all know. This is your Fermi energy level, which lies exactly midway, guys. This is also your Fermi energy level. This is your conduction band. This is your valence band. Okay. Now, what will happen? Where is for intrinsic semiconductor? It will be exactly here, guys. Now, what is going to happen for p-type semiconductor, where number density of holes will be more? This will move above, guys. It will shift it upwards. It will shift towards conduction band. For n-type semiconductor, it will be shifting below, guys. Number density of electrons will be more in case of n-type. So that is the reason this particular situation will be a n-type semiconductor, guys. For intrinsic semiconductor, the Fermi energy level exactly midway between conduction and valence band. For p-type, this will move up For n type it will move down. So as it is closer to the valence band, I can say it is n type, guys. In the same manner, transfer characteristics have been given. In the region in which transistor acts as a switch on, in which region beta? In saturation region, which happens to be the third region. Again, definitely direct questions will come based on this, guys. They're asking us which among the following are correct relations for a CE amplifier. Okay, symbols have their usual meanings, they are saying. Right, now what is R naught here? Output resistance. Ri is your input resistance, guys. Okay, so for CE amplifier it will look something like this, guys. Again, it depends whether it is an NPN transistor or a PNP transistor, right? So which of the following are correct relations they are asking? So I can take it something like this. Common emitter amplifier you take, guys, then here you are going to have some output resistance. Here you are going to have some supply, voltage supply. In the same manner, here you will have some input resistance and there will be a voltage supply. This is your base, this is your collector, this is your emitter. From here you will have base current beta. This is VBB or simply VB you can write. This is VCC or simply VC you can write, guys. This happens to be your input resistance and this happens to your output resistance. Okay. Now what are we going to get beta? Output value. If you just need to apply KVL in this loop whenever you are solving questions of uh, the amplifier, guys, when both EB and CB junction are in reverse bias, then it will be an active state, guys. So EB junction should be in reverse bias, so it will be moving something like this. So because if you apply KVL again, if you apply KVL, you will get IE in this manner, guys. Should be in reverse bias. So this will be the diode action at EB junction. At CB junction, again, if you see, you should get IC value like this. You should get IB value like this. This also should be in reverse bias only again. If you take CB diode action, you will get it something in this manner. Okay. Now, if you apply KVL in this, let us start from here and we are moving in clockwise sense beta. If starting from negative to positive means I will get VCC. Then you see, I am moving in the direction of current. Usually in the direction of current, what will happen to potential difference? It will be decreasing, guys. So I can write minus VCE. We are moving in the direction of current again, so minus IC into R naught. You are coming back to the same point, you'll write 0. So VCC minus VCE should be equal to I naught into R naught. What will I get R naught value as? You will get it as VCC minus VCE divided by I naught. Clear all of you? I naught, it is not I naught, it is IC, guys. This is how we apply KVL again. So will output resistance be VCE divided by IC? No. What will it be? It will be VCC minus VBE divided by IC. In the same manner, if I apply KVL in the other loop, guys, if I try to apply KVL in this loop, starting in this sense, moving in anti-clockwise sense, we are moving from negative to positive terminal. So what will I write? VBB. We are moving in the direction of current. EB junction should be in which bias, guys? Reverse bias, right? So you are moving from higher to lower, so potential will be decreasing. So minus VBE. You are moving opposite to direction of current. So what I will write? Plus IB into RI. You are coming back to the same point, you will get it as 0, guys. So what we can write? RI value as, you can write it as VBE minus VBB divided by I base. This is your input resistance. Clear? So input resistance will be nothing but base resistance and output resistance will be nothing but collector resistance in this case. And what is the meaning of transconductance, guys? It will always be, GM happens to be transconductance here. What will transconductance be? It will always be the ratio of output current divided by input voltage, guys. Okay, so what is output current here in this situation? Output current, what is it? In common emitter, always remember output collector, input base. So what is the output here, beta? You can write it as IC divided by what is input here? You'll get it as VCC. You will get it as VBB as your input, guys. Which among the following are correct relation for a C amplifier? They are saying. Acha, you can use this, no? Now, whatever is potential here, will same be potential here? Yes or no? Whatever is potential here, I cannot say same will be potential here, guys. No, it will not be VCE again. Okay. Input resistance is given as VBE. That will also not be correct case. IB divided by VBB, you will get both 1 and 2 are wrong again. Okay, let me cross check this question also. CE amplifier. Two amplifiers are connected one after the other in series. The first amplifier has a voltage gain decibels. Always remember, whenever voltage gain is given in decibels and amplifiers are connected in series, the resultant voltage gain will be sum of individual voltage gains, guys. So here what we will write directly, one of them has 20 decibels, other also has 20 decibels. So overall you will get it as 40 decibels. This would be the voltage gain. However, if the voltage gain is given just in numerical value, guys, then suppose if I say one is given 20, other is given 5, then what is the resultant voltage gain, they will ask you. Then you will write product of individual voltage gains, A1 into A2 you will write, guys. If it is given in numerical value and if amplifiers are connected in series, A1 into A2. If it is given in decibels, then if the amplifiers are connected in series, resultant net voltage will be A1 plus A2 again. Clear all of you? And there is some relation between your voltage gain in numerical value and voltage gain in decibels also, guys. Right? So I think you will get it as voltage gain. If I want to find it in numerical value, it will be 20 log voltage gain in decibels, I guess. Okay, so 20 decibel if I take log 20, you will get, guys. 20 log 10 voltage gain in decibels you will be getting. No, this is voltage gain in numerical value, and this will be voltage gain in decibels again. Okay, this will be numerical value. This is the relation between voltage gain in decibel as well as voltage gain in numerical value. Whenever amplifiers are connected in series, voltage gains are given in decibels. To find the resultant voltage, just add. Whenever amplifiers are connected in series, if simply numerical values are given, then in order to calculate voltage gain, you just multiply. I hope it is clear. Yes, if you see the circuit diagram shown in the figure corresponds to what they are asking, guys. Okay, now suppose I'll just take very simple logic A, B, and Y. Okay, now I want the bulb to glow. Why is the output here? I want the bulb to glow. So VCC, let us say this is plus some V. Obviously, this will be, because it is earth, it will be 0, guys. Now, if A is open, B is also open. A open, B open. Now, current will start flowing from here. Yes or no? Now, A is open, B is open. Can current flow? Can current take this path? No. So, current overall takes this path only. So, is there any voltage? Is there any output? Yes. Suppose if A is open, B is closed. Again, overall this will still be an open circuit only. Will there be output? Yes. If A is closed, B is open. Again, will there be output? Yes. But if both are closed, the whole current will be moving into the earth only, guys. Will there be any voltage here? No. So which is it? If both are operated at high voltage, you are getting output, means it is AND gate. Here you are not getting output in that case. Rest all cases you are getting the output. So it is going to be which gate, beta? It will be exactly opposite of AND. It will be an AND gate, guys. Clear all of you? Yes or no? I hope it is clear, guys. So very simple. They are just asking us in this point, will there be any voltage or not? So if A and B both are open, Will there be any voltage at this point? Will there be any current flowing? No. V naught value will be VCC only. But if both are closed, then current will be flowing in this situation. I hope you understood. Clear? Yes or no? In common emitter amplifier, the audio signal is given as audio signal voltage across the collector of resistance. So collector resistance in emitter, always remember output will be collector, input will be base. So collector resistance is nothing but load resistance, which is 3 kilo ohm. And what is the output voltage beta here? Collector is nothing but again output voltage only. Current gain, current amplification factor is given as 80. Base resistance happens to be your input resistance, guys. Right, which is 1 kilo ohm. They are asking us to find what is the power gain of the amplifier. Right, you know the output voltage. So now you know the output voltage. You know the current gain. They are simply asking which gain, guys? Power gain. They are asking. How can I write power as? I can write it as voltage gain into current gain. Beta value we know. I need to find voltage gain, guys. So how will you find voltage in common emitter amplifier? Audio signal voltage. VI value, V naught value is given. I need to find VI value. Right. So beta value is given from here. Can I find resistance gain? What is, again, whenever a term gain comes, guys, it is basically output by input. There is load resistance divided by input resistance. Load resistance is how much? 3 kilo ohm. Input resistance is how much? 1 kilo ohm. So what is resistance gain beta? 3. So how can I find current gain as? I can write it as voltage gain divided by resistance gain. Implies from this, can I write voltage gain? What is voltage gain? Beta into Rg. Beta value is already 80 into Rg value we got 3. So voltage gain is 240, guys. So what will power gain be? It will be 240 into 80. 8 4 32, 8 2 16, 19200 will be your power gain. Clear all of you? 19200 will be your power gain. Any doubt in this, everyone? Yes or no? Right. So always remember, whenever a term gain comes, it will be output divided by input. Resistance gain will be load resistance divided by input resistance, which is nothing but output resistance by input resistance, guys. Current gain will be output current by input current. In common emitter, output will always be collector. Input will always be base. Power gain can be written as voltage gain into current gain. Clear? Understood? These were some questions in electronic devices. We have few more questions, guys. We'll discuss it. If you can take a 5 minute break and come back, okay? In another 45 odd minutes, we can complete. I think so, right? So you just take a 5 minute break. Until then, I'll just cross check the other questions which I have not discussed. Okay. So please come back by 9:30 or something like that. Clear, all of you? You can take a 5 minute break and come back, guys. Thank you. Am I audible, all of you? And visible? Right. I was just going through some questions, guys, and I think uh, somewhere we did wrong. Right? So all these were correct only. Now this one, if you see, guys, see basically carbon is taken as non-metal. So energy gap for non-metals will be basically more than 3 electrovolt. Silicon is a semiconductor. It will be less than 3 electrovolt. So this is correct only. What will be at 0 degrees Celsius, semiconductor behaves as a conductor. It will behave as semiconductor only, no? Only at temperature 0 Kelvin it will behave as insulator, right? But I just went wrong somewhere there. I don't know what was going on in my mind. So at 0 degrees Celsius, semiconductor will be semiconductor only, right? Its conductivity will increase, but it doesn't become a conductor again. So this would be a wrong statement, right? In the same manner, if you look at this, guys, what they are saying, a pure semiconductor crystal has 4 into 10 power 27 atoms per meter cube. It is doped with 4 parts per million concentration of pentavalent atoms, guys. Now, how many holes are we going to? Till here, this is anyhow correct only. So, what I need to find out is what would be the number density of electrons that we are going to obtain. So, pure semiconductor crystal has 4 into 10 power 7 atoms per meter cube, guys. It is doped by 4 parts per million concentration of pentavalent atom. What is 4 parts per million now? You will get it as 4 into 10 power 6 again. These many atoms are being added. So what will be the number density of electrons that I am going to get? You will get it as 10 power 21. So if I just divide it by 10 power 21, you will get number density of holes as 10 power 11 per meter cube, or meter cube whole power minus 1 you can write. Then here also, guys, it is not n type because see, usually in p type you have acceptor impurities, in n type you have donor impurities. So acceptor energy level will be close to valence band, guys, and donor energy level will be close to conduction band. So it will go up for which case here? For n type, donor energy level will be near to conduction band, acceptor energy level will be close to valence band. So for p type it will be going below, guys. So here the answer should be p type. Okay, so these were the two changes that you should be making. And when I come to this situation, guys, which we didn't get answer as again, if you look at this, suppose if you don't have external voltage directly, here it is short circuited, if I say, then what will be VCC value? VCC value will get it as 0. Yes or no? So in that case, I can write output voltage as VCE divided by IC. So this will be correct provided there is no external output here. Similarly, it will input resistance will be VBE by IB when provided if there is no VBB, guys. This is also correct. Now, what will I get the transconductance as? I will get output current divided by input voltage. So here input voltage happens to be VBE. It is not VCE, guys. It will be VBE again. The transconductance will be wrong. So both 1 and 2 will be correct statements in this case. You just need to apply KVL. If VCC is not there, then output voltage will be VCE by IC. In the same manner, if VBB is not there, then input resistance will be VBE divided by IB. So both first and second one will be true. Third one, you should get IC divided by VBE, guys. Input voltage will be VBE there. These were the questions. Let us see a few more questions in electronic devices, guys. Now, just now we have seen the given plot of IV characteristic for semiconductor. Which will it be, guys? It is going to be certainly for photodiode, guys. Photodiode will always be operating in reverse bias condition. LED will operate in forward bias condition. Right? There is no specific biasing condition for solar cell. So it is going to represent IV characteristic of photodiode connected in reverse bias. Photodiode will operate only in reverse bias. LED will operate in forward bias only. Okay. VI characteristic of silicon diode is given. The ratio of resistance at ID value is how much? 15 milliampere they are saying. And what is the potential difference given as? Minus 10 volt they are asking, guys. Ratio of resistance at this value. So please see, at minus 10 volt, how much is the current flowing? 1 microampere or not? So what would be the resistance there? Resistance when potential difference across diode is minus 10, if I say, what will you get it as? You will get it as potential difference anyhow 10. How much is the current beta? 1 into 10 power minus 6. So I'll get it as 10 power 7 ohm or not? Yes. In reverse bias, the diode will offer very large resistance. If it is an ideal diode, it will offer almost infinite resistance, guys. Then what is resistance when current through the diode is 15 milliampere? Now you see. Here you will talk about dynamic resistance, guys. At this point, they're asking. So you will talk about dynamic resistance. So for that purpose, what I'll do, I'll name 2 points again. If I take this, what will you get here? Zero point 0.8 comma 20 milliampere. Yes or no? And if you take this, what will you get, beta? Zero point 0.7 comma 10 milliampere. So again, what are we going to get? Resistance will be V divided by I or not? So what are we going to write here? Delta V by delta I. What is change in potential difference, beta, here? 0.1, because it is 0.8 minus 0.7. And what is change in current? It is 10. So you'll get it as 10 milliampere again. Right? Between these 2 points, change in potential is 0.1. Change in current is 10 milliampere, guys. So 10 into 10 power minus 3, you will get 10 power minus 2, you will write here. This is 10 power minus 1 already. So I will get this as how much, guys? 10 will I get, everyone? I hope you will get it as 10 ohm. Yes or no? Now they're asking ratio of R when current is 15 milliampere to the resistance when potential difference across the diode is minus 10 volt. So we got 10 divided by 10 power 7. I'll get it as 1 by 10 power 6, which turns out to be 10 power minus 6, guys. Clear, all of you? I hope it is clear. If you see, which of the following represents symbol for optoelectronic device? Right? Which will be the case again? It should be in forward bias, guys. Which is going to be in forward bias, you see? Right. In this case, P is connected to higher potential, N is connected to lower potential. So here this will be your opto, means again optical light, LED they are asking, guys. LED means it should be in forward bias. Yes or no? Forward bias means P should be at higher potential, N should be at lower potential. So obviously it is there. So first case will be correct. Second case, if you see, this is a case of Zener diode again. It is not necessary for us, guys. Second case. Third case, P is at lower potential, N is at higher potential. So this will be in reverse bias. First option will be correct, guys. LED, light emitting device, you can say, or optoelectronic device. It should be operating in forward bias condition, guys. Clear, all of you? Then, whenever we consider input signal voltage is given, how much is it? Voltage gain is also given as how much, beta? 100. And input value is given as 4 sine 100 pi t plus pi by 4. They're asking what is the value of corresponding output signal in C configuration. So always remember voltage gain will be given as V naught divided by Vi beta. So implies from this, what will I get? V naught value as voltage gain into Vi. Voltage gain is already given as 100. Vi we got it as 4, which will be 400 beta. So what is output voltage here? V naught, which is 400 into sine of 100 pi t you will get, plus pi by 4 you will get. Always remember, in CE amplifier, there is a phase reversal of pi degrees, guys. So if input is given as 100 pi t plus pi by 4, output will be given as 100 pi t plus pi by 4 plus pi, guys. So what will you get here? 400 sine of 100 pi t plus 5 pi divided by 4 will be our output voltage. Always remember, in common emitter amplifier, a phase reversal of pi radian will take place. Whereas in common base configuration, output and input will both be in phase with each other. No phase reversal in common base configuration, guys. A 110 root 2 volt AC supply is given. What is the potential difference across the capacitor? Same case again. Simple value is given. So what is this 110 root 2 volt beta? This happens to be your RMS value again. Yes or no? It happens to be which value? RMS value. Now, if they are asking you to find potential difference, maximum potential difference. So whenever positive supply is there, right, positive input you have, positive cycle of input you have, then diode will be in forward bias. In that case, what is the peak value, guys? The peak value will be given as root 2 times the RMS value, which turns out to be 110 root 2 into root 2, guys. The potential difference across the capacitance will be 220 volt. Clear, all of you? Because if you see a half wave rectifier is given again, choose the correct statement. It seems the output across the diode will be 0 all the time. No. When will it be 0, guys? See, if I take again, uh, first you have negative supply, then you have positive, whatever it is. For positive half cycle, it will be conducting again. For negative half cycle, it is not going to conduct. So output across the diode will be 0 all the time. No, it is wrong. Output across diode will be like a half wave rectifier with negative cycle in the output. No, half wave rectifier will be giving only positive cycle, guys. Positive cycle you will get in output. Negative cycle it is not going to accept. In the same manner. Next case, if you see, three photodiodes D1, D2, D3 are made up of semiconductors having band gaps 2.43, 1.8, 2.52. The light of wavelength 6000 angstrom can be detected by. So again, wavelength will be less than or equal to, just now we have studied 12,400 divided by energy gap should be taken in electrovolt. Answer you will be getting it in angstrom, guys. So in first case, the wavelength up to which it can predict will be, first case what is given, 2.43 is given, guys. Whatever the values you can find out. In second case, what is it, 12,400 divided by 1.8. This also you see. Then the same manner 12,400 divided by 2.52. Okay, so if you just look at these cases, guys, so you have 12,400 divided by 2.43. This you will get 510 5102.8 angstrom, guys. Then if you also do 12,400 divided by 1.8, you will get 688.8 angstrom, guys. And if you are doing 12,400 divided by 2.52, this you will get it as 4920.6 angstrom. So they want to detect a light of wavelength 6000 angstrom. Can it be detected by using first diode? No. Can it be detected by using second diode? Yes, up to 6900 you can take. This will also be no, guys. So which diode will be helpful? Only D2 diode can detect that particular light of wavelength 6000 angstrom. Clear, everyone? So you see the truth table in this situation. Truth table for the circuit shown below is given. Now, please understand, very simple logic, A, B and Y. Okay. Now, if you talk about A here, if A is at low, B is also low. So what is going to happen? Now, A is at low means D1 is connected to higher potential. Then obviously current will be flowing through A as well as B. Will there be any current flowing through I? No, guys. Output will be again 0. If A is high and B is or A is low, B is high, let us say. What will happen now? The current will be flowing through A. Will it be flowing through V naught? No. So in this case also you will not get any output. If A is high, B is low, guys. If A is high means obviously this will be in reverse bias. B is low means all the current will be flowing through B only. Will there be any output? No. If both A and B are operated at high, then D1 and D2 will be in reverse bias. Then you can consider there will be output 1. So what will be the 0, 0, 0, 0, 1, 0, 1, 0, 0 and 1, 1, 1. First one will be the truth table for it, guys. Clear everyone? What they have given in this situation, common emitter configuration is given. Common emitter amplifier is shown in the figure. Input voltage is 10 volt, it seems. VBE value is given as 0, guys. So this is your emitter, this is your base, this is your collector. So from collector, I will have which current beta? Collector current, IC. From here, you will have base current, IB. What is the value of current gain they are asking? What I'll apply? I'll simply apply KVL, guys. First, I'll apply KVL from here to here. Okay. So I'm starting at VI. VI. We are moving in the direction of current across the resistor. So I'll write minus IB into RB. Already VBE value, current is flowing in this manner, guys. Current always flows from higher to lower potential. So we can write minus VBE will be equal to 0. Already they have mentioned that VBE value is 0, guys. So what we can write, VI minus IB into RB. VI minus IB into RB will be equal to 0. So I can write IB value as VI divided by RB. Is VI value given, beta? Yes, input voltage is 10. And if you see this value, it is 500 kilo ohm. I can write it as 5 into 10 power 5 I can write. Which I'll get it as 2 into 10 power minus 5 ampere into 10 by 10. If you do, you'll get it as 20 microampere, guys. In the same manner, now I'll apply KVL from here to here, beta. So I'm starting at V naught at 10 volt again. I'm starting, right? So what we can consider? So you can write 10 in the direction of current we are moving. IC into RC, right? You are again always current will flow in the direction of decreasing potential, guys. So what I can write? Minus VC, you are going to be 0 again. So what I can write here? ICRC will be 10 minus VC. VC value is already given as 4. So will I get it as 6 or not? So what will IC value be? 6 divided by RC value is 2 kilo ohm. 2 into 10 cube I can write, which turns out to be 3 milliampere. They are asking us to find out what is the value of current gain. Current gain will be output divided by input, guys. So output is 3 milliampere, 3 into 10 power minus 3. Input is 20 microampere, 20 into 10 power minus 6, guys. So if I just send it to numerator, I'll get it as 3000 divided by 20, which turns out to be 150. You should be aware of all the formulas in case of transistors, guys. Basic formulas, gain means just like efficiency, output by input. Current gain means output current by input current. Usually common emitter amplifier will only be given. So for a common emitter amplifier, output will be obtained at collector, input will be applied at base. Okay, so these 2 points you should be aware again. I hope it is clear. The circuit shown, if the diode is in forward bias, they are asking in the circuit shown in figure, if the diode forward voltage drop is zero point 0.3, potential difference between A and B they are asking, guys. Here it is given as 0.3 again. So let us see. We'll just apply KVL again. So I'll write VA. 0.3 volt is given, guys. Right now you see, you're moving in the direction of current. So what will I get? Minus 0.2 into 10 power minus 3 into 5 kilo ohm, 5 into 10 cube. Okay. Then if it is in forward bias, so it is going to P will be at higher potential or not. So if it is in forward bias, I can replace it like this. Okay. So what are we going to get? Minus 0.3. Then again, same current will be flowing, let us say. So you'll get it as minus zero point 0.2 into 10 power minus 3 into 5 into 10 cube will be equal to VB, guys. This is how you'll apply KVL. What are we going to get? VA minus 1 minus zero point 0.3. This will also be minus 1 will be equal to VB, guys. So VA minus 2.3 will be equal to VB. What will I get VA minus VB as? You will get it as 2.3 volt, guys. So that would be potential difference if it is in forward bias. Okay. Understood, all of you? If it in reverse bias, obviously this will be open circuit. Hole will be flowing through the capacitor. So there will not be any potential difference between A and B point because there is no conduction going to take place here. Figure shows the transfer characteristics of a CE amplifier. Which of the following is incorrect statement, it seems? Vi is less than zero point 0.5, transfer is in cutoff mode, correct statement. Vi is equal to 1 volt, it can be used as amplifier, correct statement. Zero point 0.5, it is in active state, no, it is in cutoff state. If Vi is equal to 3, it can be used as switch which is turned on, correct statement. Which will be a incorrect statement, beta? Third one will be an incorrect statement. Just now we have discussed which region will be active, which region will be cut off, which region will be saturation, guys. Three amplifiers are connected in series, it seems. How are they connected? They are connected in series. And are the voltage gains given in decibels, guys? No, you see just numerical values are given, right? So what will be the peak value? The output signal voltage they are asking. So what is the total voltage gain that I am going to get? Voltage gain I'll get it as, because it is numerical value, only numerical value is given. So I'll write AV1 into AV2 into AV3, guys. In decibels means you'll add. So here what I'll get? 10 into 20 into 30. So what is the voltage gain? Here you are going to get voltage gain as 6000. And how do you write voltage gain as? It is always going to be output voltage by input voltage. This is 6000. So they're asking output peak value. So V naught value will be 6000 into Vi, which I can write 6000 into 1 millivolt is given, which is 10 power minus 3. So 6 volt will be the peak value. Clear? Yes or no? I hope it is clear, guys. Assuming that the diode is ideal, the output waveform for the circuit shown in the figure they are asking. Now, suppose if I assume that the input is something like this, guys. Input is already given to us. It is something in this manner. So we'll take it something like this. This is our input. Okay. This is your Vi value, right? With respect to time, you can take input voltage. Now you see from this time to this time, right? You see this will be kept at which voltage? This point will be maintained at 20 volt. This will be maintained at 0 volt. Yes or no? So here, this will be at higher potential, guys. So conduction will be taking place. From where to where? From, you can say, 0 to 5 volt. Then we have from 5 volt to, see, if I assume this to be 0 volt, guys, very simple logic. If this is 0, automatically this will be 5. So I'll take this as 5. If this is 0 and this is also 0, what is this? 20 volt, let us say. Suppose no conduction is taking place. Here you have 20 volt, right? Till input voltage is 0 to 5. This will be in forward bias. So if input voltage is varying from 0 to 5 volt, it is going to be in which bias, beta? Reverse bias. Yes or no? Because uh, P will be at lower potential. If it is varying between 5 to 20 volt, then I can consider it will be in, diode will be in forward bias. Okay. So as you can see, so in this situation, what is going to happen? Let us see, guys. They're asking us to find what will be the output waveform if the input value is varying from 0 to 5 volt. P will be at lower potential compared to N. So this will be in reverse bias. So I'll get the output voltage. Again, output is obtained across these 2 points. Yes or no? If you just try to understand it in a proper way, guys, between these 2 points, right? Now, when will conduction take place? Conduction will take place if this end is more than 5 volt. So up to 5 volt, you don't have conduction. So 0 to 5 volt, what we can say, V naught value will be 20 volts only, guys. Okay. Rather than saying 20 volt, it would be better if I say V naught value will be equal to applied voltage. But if it is 5 to 20 volt, then it is in forward bias, then it is conducting. So in this situation, what will be output voltage? It will be exactly equal to 5 volt. This is how you will be using this. So you can just see, I will go with third option as the answer for this, guys. I hope you understood. It's a very simple logic to understand. If conduction is taking place, I want potential difference between these 2 points. I want potential difference between these 2 points. Yes or no? I have it something like this, guys. I want potential difference between these 2 points. This is given as 5 volt. Okay. Now please, very simple logic. Between these 2 points means it will be potential difference across the diode as well as 5 volt. As simple as that. Yes or no? Now, if it is in forward bias, then what I'll do? It is simply short circuited. So what will be potential difference across these 2 points? 5 volt. But if it is in reverse bias, then what will happen? This will be open circuited, guys. So I'll get a circuit in this manner. Then input voltage only will be our potential difference. That is the basic logic you should remember. So here it is varying from 0 to where, beta? It is varying from 0 to 20. Yes or no? It is varying from 0 to 20. Now, because it is varying from 0 to 20, when in applied voltage is varying from 0 to 5, P will be at lower potential. So this diode will be in reverse bias. It will behave as an open circuit. So when it is behaving as an open circuit, potential difference between these 2 points will be applied voltage itself. Whereas when the applied voltage became more than 5 volt, then here P type will be at higher potential. It will be in forward bias, guys. So in that case, conduction will take place. Potential difference between these 2 points will simply be 5 volt. Okay. So that is how we will say 3 volt will be the answer. Whereas when negative voltage is applied, always P will be at lower potential only. So when negative potential is applied, the output voltage will be equal to applied voltage only, guys. The whole of negative potential. In a p-type semiconductor, which of the following statement is correct? Which will be majority charge carriers? Holes will be majority charge carriers, guys, and trivalent impurities are being added. So holes are majority charge carriers and trivalent atoms are your doping agents, guys. An unbiased PN junction diode. In an unbiased PN junction diode, what they have given, guys, here? Holes diffuse from P region to N region. Why? If you take unbiased PN junction, P will have more holes, N will have more electrons. So diffusion of holes will be taking place from P to N because hole concentrate due to concentration difference it will happen, guys. Hole concentration in P type is more than the hole concentration in N type. Clear, all of you? Diffusion will always be taking place because of concentration difference. Drift will be because of the applied electric field, guys. The whole concentration in P region is more as compared to N region. Holes will be diffusing from P to N. Electrons will diffuse from N to P. Okay. An input signal of 50 hertz is applied to a rectifier circuit. What will be output frequency? Always remember, if it is a half wave rectifier, output frequency will be same as input frequency. But if it is a full wave rectifier, output frequency will be double, guys. So if it is full wave rectifier, is it 50? No. If it is half wave rectifier, it is 50? Yes. If it is half wave, is it 100? No. Is it 150 for full wave? No. So it will be 50 for a half wave rectifier. Always remember, for half wave rectifier, output frequency will be equal to input frequency. What's the incorrect statement they are asking, guys, in this? Phase difference between input signal and output signal C amplifier is pi. Just now we have done. Yes. Power gain is current gain into resistance gain. Is it correct? Is power written as I into R? No. This is correct. Transconductance is current gain to input resistance. Sorry, power gain is V into I. Choose the incorrect statement they are saying, no? Power, can I write it as I into R, guys? No, it is V into I. Transconductance will be current gain by input resistance. Yes, this will also be correct, guys. So basically, when I talk about transconductance, it is the ratio of output current divided by input voltage, guys. So if I multiply input current, let us say in common emitter configuration, IB by delta IB, if I do, what will I get this as? Delta IC divided by delta IB into 1 by delta VI divided by delta IB. This is what? Current gain. Into 1 by voltage by current is nothing but resistance. Which resistance? Input resistance. So I can also write transconductance as the current gain divided by input resistance, guys. I hope it is clear. Which of the following is called universal logic gates, guys? And NOR are called as universal gates because we can derive all the other gates using NAND and NOR gates, guys. Among the following is used in unbiased condition for its proper operation. Unbiased condition, LED to forward bias, Zener diode reverse bias, photodiode reverse bias. Solar cell will be in unbiased condition. What will happen to width of depletion layer of a PN junction, guys? Right? Whenever we talk about width in forward bias, guys, what will happen? In forward bias, thickness of that particular layer will decrease, whereas in reverse bias, thickness is going to increase, guys. So it is less with light doping, more with heavy doping. It is independent of applied voltage. It is increased under reverse bias. It will be increased under reverse bias condition would be the correct statement. Okay. Basically, diffusion current is inversely proportional to electric field strength, and drift current will be independent of electric field strength. In forward bias case, diffusion current will be less than diffusion current will be more than drift current. So electric field strength will decrease in depletion layer. Similarly, thickness of the field will also decrease in depletion layer in forward bias. Reverse will happen in reverse bias condition, guys. V1 and V2 are given. The voltages V1 and V2 of the arrangement will be how much they are asking. Again, I'll simply apply KVL, guys. So V1 and V2 they are asking. So let us see from here to here. I'll apply KVL from here to here, guys. So what are we going to get? 6. Now, if it is at forward bias again, so I'll apply minus 0.6. Should be equal to, we are reaching second point. So what will I get V2 value as? Directly I'll get 5.4 volt. Yes or no? In the same manner, right? You talk about this here in this situation. If I say current always starts from here, let us say I2 current. Here you will have some I1 current. It is entering here, guys, into a lower potential again. This will be I, which is I1 plus I2. Now, if you apply KVL from here now, I'll just use different color. Let us say I'm applying KVL from here, guys. So what we can apply now? 6 minus I1 into 10. But if you just look at this is kept at 6 volt, but this is kept at 3 volt only, guys. So here diode will be in which bias? It is going to be in reverse bias. So there it is not going to operate here, guys. So or it will behave as an open circuit. So I can directly write, if this is 6, there is no conduction taking place. VI value will also be equal to 6 only. So 6 comma 5.4 volt should be the answer for that. Clear, all of you? Here there will not be any conduction. It will behave as an open circuit. If you see, which of the following gates correspond to the truth table? Which gate they are asking, guys? Can you please tell? 0 0 0 0 1 1 1 0 1 1 1 1. Is it basic again, or gate or not? To open, no output. Rest all output means or. To closed, output is there. Rest all output is not there means and. And reverse of or will be nor. Reverse of and will be NAND, guys. Peak voltage in the output of a half wave rectifier they have given with a sinusoidal signal without filter is 20 volt. DC component of the output voltage they are asking, guys. Peak voltage of the output is given, half wave rectifier. DC component of the output voltage they are asking. So what we can write here? Peak voltage in the output of a half wave rectifier is given. So V naught value is given, which is 20 volt. What is the DC component they are asking, guys? So what we can write? Can I use the concept of half wave rectifier is given, no? So in half wave rectifier, what will be the output value? It will be input divided by root 2. Yes or no? Peak voltage in the output of half wave rectifier with a sinusoidal signal without filter is 20 volt. DC component of output voltage they are asking. So peak value is given, guys. So maximum value is given as how much here? 20 volt is given, peak value. DC component of the output voltage they are asking, guys. So from this, can I use a concept called as, we have form factor, which is, then we have ripple factor also. Okay, let me just cross check this question. Which among the following expressions is incorrect for uh, transistor they are saying, guys? So what is this? Transconductance is current gain by input resistance. Just now we have seen it is correct. Transcurrent is output current by input voltage. Just now I've said it is correct. So I can also write, very important, second one is very important, guys. Voltage gain can also be written as transconductance load resistance. Load resistance nothing but output resistance. This is also correct, guys. Which will be wrong? This statement will be a wrong statement. Clear, everyone? Transconductance is also always the ratio of output current to the input voltage. Can also be given as current gain by input resistance or voltage gain by load resistance, guys. And what they have given in the circuit to us, in the circuit shown in the figure, the input voltage is given 20 volt, VBE value is given as 0, VCE value is also given as 0, beta value is 125. Again, simply apply KVL, guys, from here to here. So what will I get? VI. From here you will get IB value. From here you are going to get IC value, guys. So VI minus IB into RB. Current will always move from higher to lower potential, minus VBE. You are coming to earth point, it will be 0, guys. Simply applying KVL. So 20 minus IB into RB value is 0.5 mega 10 power 6. VB is anyhow 0, you can take it as 0. So what will IB value be? 20 divided by 0.5 into 10 power 6. Okay. So which I will get it as 200 by 5, 40 microampere you will get. So IB value is 40. So what will IC value be? Beta value is IC by IB or not? So beta into IB you can write. Beta is 125 into 40. Okay. So I'll get it as microampere again. So which is 500 you will get, which is 500, 5000 microampere you will get, guys, which is 5 milliampere. 40 microampere and 5 milliampere should be the answer for IC and IB. IB and IC respectively. Figure shows a logic gate. Whenever such cases are given, guys, you will assign some values. Higher value will always be 1. Lower value will always be 0. This is higher value 1, 0, 1, 1, 0, 1. Here you assign 1, 1, 0, 1, 1, 0. If you see the output 1, 1, you are getting 0. 0, 1, you are getting 1. 1, 0, you are getting 1 only again. 1, 1, again you are getting 0. 0, 1, you are getting 1. 1, 0, you are getting 1. So 1, 1, you got 0. Okay. 0, 1, you got 1. 1, 0, you got 1. 1, 1, also you got 0. 0, 1, you got 1. So when both are operated at high voltage, are we getting output? No. So whenever both are being operated at high voltage, if we are not getting output, it will be a case of which gate? It will be a case of NAND gate, guys. Whenever two operate at high, no output, rest all cases output will be there. Clear all of you? We have done this just now, right? 110 volt AC supply is given. So what is the potential difference? Potential difference V naught across the capacitor. 110 is RMS value, guys. So it will be 110 root 2. In the same manner, the circuit shown here corresponds to which logic gate they are asking. Now, if you see, if only A is closed, if both are open, will there be any output? No output. If only B is closed, will output be there? Yes, because current will be flowing in this manner. If only A is closed, will output be there? Yes, current will be flowing in this manner. When both A and B are closed, will output be there? Yes. So which is the truth table? It will be corresponding to OR gate, guys. A red LED is constructed from a PN junction diode using gallium arsenic phosphorus. The energy band of the corresponding material of the diode they are asking. So what is red LED is given, guys. So whatever is the wavelength of red light, you can use that. So energy gap will be equal to 12,400 divided by wavelength of red light, guys. Usually it will be given again, so you can be calculating this particular value. Next case, if you see at room temperature, pure silicon has equal number of electrons and hole concentration. Ne value is equal to nh value, which is 1.5 into 10 power 10 per centimeter cube, guys. Doping by a trivalent atom increases hole concentration. So what is our new nh dash value, guys? It is increasing to 4.5 into 10 power 22 per meter cube. There it is centimeter cube, here it is meter cube, guys. Centimeter cube means I can write it as 10 power minus 6 again. So this will become 1.5 into 10 power 16 per meter cube, guys. So always remember here Ni and Nh both are same. So what will like Ne and Nh both are same. Intrinsic charge concentration formula will be Ne into Nh always, guys. Okay, that would be same. So what are we going to get? I want to find Ne dash now is how much. So what we can apply with intrinsic charge concentration is same. I can write Ne into Nh will be Nh dash into Ne dash. So what will I get Ne dash as? I can write it as Ne into Nh divided by Nh dash. So if you multiply both of them, you will get 2.25 into 10 power 32 you will get divided by 4.5 into 10 power 22 you will get, guys, which will be 1 by 2 into 10 power 10, or I can write it as 5 into 10 power 9 per meter cube. So always remember this intrinsic charge concentration square will always be the product of electron concentration into hole concentration. Clear everyone? Yes or no? So what I'll be doing tomorrow is what all uh, questions. Tomorrow is Friday, I believe, right? We will try to wind up tomorrow itself, guys. Hopefully, right? What all questions we have not done, I'll just identify those and I'll discuss those questions, guys. Apart from that, whichever topic you want me to discuss, I'll be discussing those. I have already shared the brief notes of heat. If possible, we will just review some very important topics in NEET, like calorimetry, conduction formulae, radiation formulae, right? In thermodynamics, what would be how will you find out the area, how will you find out the work done in different processes, heat engine cases. These important relations, kinetic theory, so it's not that much essential again, right? Because you already study that in gaseous state also. So we will be discussing tomorrow also, just like today. We will take little bit more session, and for more time, we will take the session for more time, and we will focus on completing whichever questions we have not done first. Then we will do some important questions related to heat. Then we will also focus on the topics which you want me to discuss. So please keep a note of all the things which you want, and we will discuss all those things in tomorrow's session. Is that clear, all of you? Clear, everyone? Right. So that's it from my end for today. We will be meeting tomorrow. Till then, take care, everyone. Thank you all. Bye, all of you.
So would you be doing it, sir?
Tomorrow we'll be doing it.
No,
हाँ
sir. I
दैट
mean,
आई हाँ अभी कर रहा हूँ.
sir, 30 minutes का मिल जाएगा.
11 o'clock तक दूंगा टाइम. ठीक है.
Okay.
राइट. चलो, थैंक यू गाइस.